To kick things off this afternoon, I'd like firstly to introduce my colleague, Nigel Fraser. Nigel is one of the industry advisors at Buildoffsite. His career has spanned the automotive, aerospace and construction sectors, mainly developing products and design and technical standards. He's been involved with Buildoffsite since its formation and recently led the research into how design processes are working during the COVID-19 pandemic. Nigel, I hope you're around somewhere and perhaps you'd like to take over, please.
I'm here. Can you see me?
Hello, Nigel. Yeah, thanks. You okay to take over?
Yeah. Sorry about that. I'm not sure what was happening. Okay, so as Tim mentioned, Buildoffsite commissioned some research into how design management was functioning during the lockdown with a lot of remote learning. And one of the things that came out of that was some insight as to how systems engineering in particular could help us work remotely and more autonomously. And today we've got a panel of 4 experts who have all got experience of using these sorts of techniques in a construction world or studying them in the construction sector. So we're going to be kicking off with Thomas Garcia, who's been very much involved with the HS2 project, looking at the civil engineering side of things, and has worked with Buildoffsite on looking at how to design bridges and viaducts, for example. We have Dr. Chris Millard, who's at Laing O'Rourke and has applied the systems engineering both there and in a prior life in the airports. We have Vince Fenson from Polypipe, who are looking at assemblies and modules that can be brought into larger buildings. And then we have Professor Jennifer Whyte, who's been looking at systems engineering and configuration management for quite some time, and can tell us a bit about what the academic world has been looking at, and can give us some insight and help into using some of these techniques in construction projects on a wider basis. So this image was taken from the cover of the Buildoffsite report, which is downloadable from the Buildoffsite website. It covers a wide range of aspects of the learning from the pandemic, and we've had a number of webinars which are also available to look at different aspects of that. Not least, how we create effective teams and get to know each other and mentor and develop personnel within projects and within companies. We also looked at the way that offices have had to be reconfigured, and the different role that offices are likely to play in the future post pandemic. But going back to the piece of work that really initiated this session, one of the things that a lot of people commented on at the earlier stages of the pandemic was that they were spending a lot of time in meetings, and those meetings were quite large, and quite often the whole sort of project team was getting involved, and that has both positive and negative aspects. The positive aspect is a lot of junior people were saying they were getting to see things that they didn't normally get exposed to, and they had a better understanding of the project. But on the other hand, the meetings were seen as being necessary to enable people to coordinate work. And what we're looking at this afternoon is hopefully a way of being able to coordinate work, but allowing people to work relatively autonomously, knowing that what they're doing is going to integrate with the work other people in the project are doing. And we'll be kicking the ball off with Thomas Garcia from HS2, who obviously it's a very complex engineering project, and a lot of different aspects, both systems both systems and geographically to coordinate and integrate. So it's been quite a key aspect of that project and how it's been set up. But I think you'll find with the other examples that we've pulled together that there's learning from that that's applicable to all sorts of building types and the construction sector in general. Okay, so can I hand over to Thomas?
Thank you, Nigel. Good afternoon, everyone. Yeah, I think that we all have suffered the impact of these strange things, but probably because of the nature of high-speed 2, and we already had some systems that helped us coping with it a little bit better. With so many locations, as Nigel said, and so many professionals working from different places, where we had to have a system to do it anyway. So in any case, high-speed 2, as a client, is the systems integrator. We are responsible for delivering something that works, a new railway that works and is properly integrated. So with so many professionals, so many disciplines, so many contractors working in different places, in different countries, basically, our designers are working in Spain, in France, in England. So basically, we need to have a system engineering process. It's essential just to coordinate all the main work: civils, stations, rolling stock, railway systems, conventional network interfaces. Each of those have a lot of subsystems, and everything needs to work in a seamless way. So the purpose of the system engineering management plan is to align the whole organization, all the supply chain, and everyone to get a common goal. And it's around a common understanding of what the high-speed 2 railway is and how to be delivered in a coordinated way. It's the central reference for all of us working in high-speed 2. It's the overarching approach for how we design remotely, how we coordinate, how we achieve what we want to achieve. And basically, it goes from the sponsor requirements to how operations and maintenance concepts are to be met, the definition and the interaction, the interfaces between the different systems, different constraints, different requirements, how each of the systems are designed, and some of them are designed by high-speed 2, and some of them are designed by our supply chain. And all the technical processes and tools to manage all the interfaces, all the risk, all the changes, everything that needs to be done. And also it defines the organizational roles and responsibilities for each of the aspects that we have discussed. And that's a brief overall of what we're trying to achieve with the high-speed 2 system. Really is quite complex, but I just wanted to provide like a high-level view of that. And that's me. I'll hand it back to Nigel.
Thank you. In fact, I'd like to invite Chris to listen. Oh, sorry, I beg your pardon. Just to set the context. There's something at the heart of a systems engineering process, which is known quite commonly as the V diagram. And if we look at this simplified version of it, just to give you some sort of background before we get into some more detail, it's something that one progresses down the left-hand side and then returns up the right-hand side. And we start off obviously with client requirements and how those can be verified, and look at the sort of the system as a whole, what the overall architectural concept is, and then break that down into how that can be modularized, and then within that, what sort of components are required and to be developed. And then sort of corresponding with each of those layers, there are requirements to test and validate them. And as we put the components and the modules together, we need to integrate them and test the integrated aspects, and then we need to test the whole system, and then we have to hand over the facility to the client. And it's all about defining what it is we need in progressive detail, how we're going to validate that we've got what we set out to achieve, and how we put them all together and deliver the project as a whole. So this sort of V diagram theme will come up again in a minute, and you'll see how that can be applied in real life. And at this point, I'll hand over to Chris.
Thank you, Nigel. And just to build a bit of colour around both what Thomas has said and Nigel, we're in a very complex world, remotely working, and we need to integrate our activities together so that we are completely confident in the outcome of our technical endeavours will deliver what we set out to do. So the question at the top of that slide, how do you know it will work, keep working and stand the test of time? I first asked that question, in fact I was asked that question when I was the technical director of the Terminal 5 programme back in early 2000s, where I met Nigel for the first time. And we answered that by applying and leading the application of systems engineering to the whole project, and particularly the engineering systems and integration of engineering and IT systems. We followed the simple V diagram, and the V diagram became well embedded, not just in the Terminal 5 project, but across how we undertook capital projects at Heathrow. It is very flexible, and if I can move to the next picture and just build on this one about how you get from an idea that I want to build a modular building that might look like that. I want to have a factory that makes the modules and I want to assemble them and build it. How on earth do I know that when it's built, it will work and keep working? And here's the example, and this is the approach that we've taken in Laing O'Rourke. So this is a very similar application to that which I led back at Terminal 5 all those years ago. And we start a journey along our path on the top left of a traditional construction approach, moving to our current operating model, whereby, as you know, we lead the industry in our offsite manufacturing solutions, but we're nowhere near where we would ideally like to get to in terms of removing site activity to factory activity, driving route productivity in what we do by eliminating tasks or automating tasks, and massively simplifying site assembly. And we set ourselves a target. We said DFMA, which is our name for our operating model, 95, 95, 95, top left there. So call that the client target. 95% of the work we want to be completed in the factory. We want to reduce the workforce that we need to assemble on site by 95% compared with a conventional building solution. And we want to do it in just 5% of the time, so a 95% reduction in the time to build. Highest level objective, one step down. What's the brief? What's the key requirements? Stepping down the V, starting to determine the requirements in a more detailed way. How do we want to build it? What do we want to get out of it? What's the performance we want of the building? USPs, next level down. What do we want to stand out? Is it floor stiffness? Is it acoustic performance of the building? Is it thermal performance of the building? Is it the quality of air? Is it just the quality of robustness of build? What are the things that we want the building to stick out? And then that allows you from those requirements to get to the next level of detail down, a basis of design. And it's here that by going through this simple stepped, ever more detailed requirements basis, you can start to see how, if you have remote teams, you can then begin to align them about delivering sets of requirements. Because each time you do a step down, you have to ask yourself the question, what evidence have I got that, for example, the basis of design will, when built, deliver a building that will meet the USPs, which will meet our briefing requirements, which has the capability of meeting DFMA 95, 95, 95 as a target. We go a step lower, we get to the scheme design, we build a reference model, pick a part of the building and detail it thoroughly, and then we do detailed design, the manufacturing process integration about how we will build it. Again, ask those same questions. How do I know that detailed design and that manufacturing process has the capability of delivering me what I require in my scheme design and will integrate to create what I want in my basis of design? There are many tools that enable us to do that. be it simulation tools, analysis tools, straightforward technical due diligence reviews that can be easily facilitated online in a systematic process, expert reviews. That facilitates then going up the other side, which is as we make this in reality and we drive to complete what I'd call a resultant design engineering program, we do the detailed design and validation calculations and simulation, and then look across and say, does that give us what we set out to achieve in the detailed design? We take the elemental test plan and say, well, if we complete this test plan, are we verifying the designs that prove that that will deliver the scheme performance? We then take the elemental plan and we look at modules, the next level of assembly up, if you like, and take a modular plan and say how this comes together as a modular or as a single apartment. How does that, when tested, how do we prove that the basis of design is met? How do I prove my acoustic performances as meet what the base of design is? Take it one step further. What's the tests you want to do on the whole building to validate that and build those in? And by not necessarily always sequentially going down the left and up the right, by considering that V diagram as a holistic model and using it to guide to plan and execute a program and to plan how you set it up, how you allocate tasks, and how you subsequently execute. It is a really simple step of the application of systems engineering, which I'm sure will help us in our technical endeavours through the what isn't just a pandemic crisis, but will be the way we want to run our engineering programs going forwards, because I see a great value and just come off a call with some folk from Spain, bringing some new skills into our business that would have been difficult to tap without being able to just sit comfortably in and work in a virtual environment. Thank you.
Thanks, Chris. Can we move on to Vince and have a look at something that is at the next level down in terms of detail?
Thanks, Nigel. Thanks for that. Well, so I mean, what's coming up? It's a worked example of what we're actually doing, of an element of an overall project that you've just seen in Chris's chart, really, which is the MEP package, the mechanical, electrical, and plumbing package. And really, I'm using it as an example to describe what we're doing at Polypipe Offsite. So, two main slides. There's the what. So it describes the outcome that we're building. So you'll get an idea of what we're about, what we're actually producing here. And then the second slide just lifts the lid on how we're going about it and how we're deploying a lot of these, a lot of the rigor, engineering rigor, and a lot of the techniques of a system engineering approach in practice, how we're actually doing it. And hopefully, as we go by the time I've finished in a couple of slides' time, it will be apparent the benefits that flow from that as far as the MEP package is concerned. So, in summary, what you've got here is an overview of a single bed apartment and the various deliverable items that we supply into that single bed apartment. It's a useful example because it highlights all of the individual packages that we supply onto that. I'll just list those out. Shown top left there, you've got a couple of examples. So these are deliverable items that we supply out. In summary, you've got a pre-prepared hot and cold plumbing and manifolds and send and receive going out to your radiators. But all of these assembled here on a utility assembly. So this forms the backboard of a utility cupboard. Inside the utility cupboard, you've also got your MVHR. Many people don't know, but New Air is part of the Polypipe group. So it's not a problem for us to integrate the ventilation systems as part of our offer. And just shown here, you've also got the runouts going out to the kitchen, which is to the left of that assembly, top left there. So that's going to the underside of the kitchen sink, hot and cold, and then the drainage running out. Bottom left there, you have the photo of a kit. That is a pre-assembled kit that we produce for the ducting arrangement that sits within the ceiling joist, the ceiling void at the top of the module. Usually that graphic there on the right-hand side rotate so you can see the various schemes. But in essence, basically we go from the digital model and we generate a kit of parts from the digital model with a parametric bill of materials, which we then use to program the CNC equipment downstairs. If we can go on to the next slide. So this is a bit more color on how we're actually working, and hopefully you'll see basically the points to make here is I'm picking up on a lot of the themes that were highlighted this morning. So early involvement is key to us, design rigor is key to us, and actively being involved in that design process is absolutely key. There is that back and forth, so as we unpick the V and go up the other side, we are going around that loop of identifying the customer requirements, the performance requirements, doing initial design, analyzing, verifying, and validating. So I'll come to that in a second. Here are the main steps of how we go about offering what we do. Typically, we start with the Revit model, the general assembly, the Revit model for the overall building type. So here is a 3-module townhouse. We will overlay onto that any M&E detail which is available at that stage. Normally at this stage, it will be things like the position of sawn and vent pipes and any incoming water utilities. We will then take that detail and zoom in area by area, room by room. And this is where we get into that cycle of identifying requirements, design, analysis, and verification in order to, in 4, suggest deliverable items. The whole point there is we're trying to maximize the amount of pre-assembly that we can do on a single delivery so that we're eliminating a potential complexity further down the line. Now again, because we have the overall model, accompanying that sub-assembly in image 4 there is also a kit of parts that enables all of these to be connected together. And then, as I've mentioned before, we then take, as soon as we have a design freeze in inverted commas, but as soon as we have that design signed off by the customer, here its status goes green, and we then use that to generate the DXF codes for our CNC equipment. The backing board that you can see there is cut by CNC. It's routed, any detail is routed out by CNC. We have a laser etcher that etches out the center lines of the pipes and any clip positions onto there as well. So that basically we undertake to operate under the principles of digital twin. So our tolerances are plus or minus a millimeter. There is an obligation on the other side. So there's a mutual obligation for our customers that when that item is then delivered into the factory, the bits it is mating with have to also be where that frozen design said they were going to be. So that's a mutual obligation on both sides. But fundamentally, and to pick up on the theme, really that was one of the first that Sam Stacey mentioned on one of his first slides, this is a design-led proposition to deliver against the performance spec. So the traditional procurement approach in construction really doesn't work in this regard. We need to be involved in that early stage design piece, and then we undertake to deliver the digital twin, and we deliver that line side. So in summary, that's the proposition.
Thank you, Vince. Can we move on to Jennifer?
So I'll just start talking, and my slides may arrive. So I'm Jennifer Whyte. I'm from Imperial College London, and I'm going to offer 3 insights from research related to this topic. And the first is really that systems integration focuses us on project deliverables and outcomes. And, to follow up on what Vince said, we need the procurement processes that allow that focus. And the construction playbook has certainly been something that government's been working on to support that. But that focus on deliverables and outcomes is really important, I think, in terms of, especially in this digital world where people are distributed. Now, we've written a paper where we were trying to make that case in the project management community. It's called Reframing Systems Integration, a Process Perspective on Projects, and you can find it online. It's on ResearchGate. And there was some resistance, I have to say, from the research community around project management to that argument, that focus on project deliverables and outcomes. And that's partly because the research community is concerned that that's about formal organising. And so I want to emphasise that we need formal and informal organising, but it needs to be focused on those project deliverables. Projects deliver systems. So that's my first point, my first insight from research. The second point that I would like to make is that we therefore, because projects deliver systems, we need to focus on interfaces and change. Yeah, so we need to be focused on the deliverables and the ends, not the activities and the means, but that pushes us. So that's the first point around project deliverables and outcomes, but that pushes us to this second point of being interested in the interfaces between work and changes in those interfaces. And if we can go on to the next slide, then there's some work that we did behind that, looking at the way that some big projects, so Crossrail, but also CERN and Airbus, how they on their projects manage change at those interfaces. The final point that I would like to make, and I'll be quite brief so that we have a bit of time for discussion. The final point that I'd like to make is that if you focus on deliverables and outcomes and you're interested in interfaces and change, but you're moving into this world of offsite delivery, then that starts to shift the focus actually from focusing just on the project to focusing on the products and the interfaces and the change between products. And it takes you into this world of platform design and reconfigurable platforms of products that you can use across a portfolio of projects. And that's work that I've got involved in through the Transforming Construction programme, and I know Sam Stacey's on the line, but particularly through the Transforming Construction Network Plus, that's involved a number of universities coming together to understand how these processes are reconfiguring the industry. And so those are my 3 points, my 3 insights from research. The first one here on project deliverables and outcomes, the second one around interfaces and change, and the third around the way that this starts to shift us from thinking about projects to products. Thank you, I'll leave it there.
Thanks, Jennifer. So we'll now be moving into the Q&A phase.
So the first question we have is from Andrew Powell, and he's asking, how do we ensure that the metrics we use drive the right outcomes ends, not just the method of delivery? For example, a nature-based infrastructure project may be the most suitable solution, but it also may have minimal MMC potential in terms of offsite PMV compared to hard engineering.
Okay, Susan, that came up in the previous session, actually.
Oh, I do apologise. Please excuse me. So is the next question from Doug Waters, asking about through the use of detailed targets.
Yeah, I'm afraid I can't see the questions. So I think those relate to the earlier session before lunch. So
Okay.
if Susan, if you could keep your eye on for any new questions coming in.
Absolutely.
To get the ball rolling, I'd just like to pick up on where Jennifer left off in a way. Coming from aerospace and automotive into construction, I was quite surprised how task-focused construction project plans tended to be, rather than deliverable-focused, which tended to be more common in the product world. And I have seen the benefits of having a deliverables-based approach, and not just from a design perspective, but also from a project management perspective, because it's a lot easier to assess how far you've got at a project if actually you're looking for a particular level of design or a particular test plan or a set of test results, or the agreement with a stakeholder on a certain aspect of a project. So it is quite a quite an interesting difference, but it is quite enlightening when you experience it. Jennifer, what were the sort of areas where project managers felt it was most difficult to do that?
So I guess I would ask other people on the panel that question. So we were observing particular challenges around managing through the process of the project, right? So people set a project up and they put a lot of effort into how that project is set up, but then, you know, changes do occur through the project, and you can argue that maybe change shouldn't occur, but the nature of this, particularly large projects, is that changes do occur. And so the challenge of getting design fixity so that you can take stuff off site, but also managing where there are changes that are legitimate to make in the process, and also when you're going to say no to change. You know, I think that's something that we've seen people struggle with, or, you know, it's an inherent challenge of these kinds of projects.
Okay, Thomas, would you like to come in there in terms of how change is handled within your project?
Well, yeah, sure. Thank you, Nigel. I think we have a change process, basically, and as Jennifer said, well, you arguably could say that there shouldn't be changes, but there are always changes. It's very difficult to set out from the day one what you need to achieve. So there are changes caused by many reasons. Not to forget, for instance, engagement with third parties, for instance, planning authorities. It is. In many cases, we don't know what the final product will be, and it's influenced a lot by the engagement with the public. So sometimes we need to change. So we have an internal change process, of course, where we need to analyze the cost implications, program implications, risk, performance, maintenance, carbon footprint, all the aspects that you would imagine in a big project like this. So it's not always easy. It's not black or white. Design is a balance between competing requirements many times. So trying to get that balance right, well, it has different interpretations. So basically, we are trying to follow a very strict process, but it's not always easy.
Okay, and Chris, in terms of acting as a sort of a product integrator or integrator on a large project, how do you see this change management process being different?
And at risk of being shot by all of the participants on the call, I think the subject of change management, as for example exists in aerospace or an automotive company, that scale of detail is not understood in the construction sector. The issue that drives it in those sectors is a manufactured product. And where you have a manufactured product that's serially being manufactured, I don't know, let's take a plastic molding for a inside of a car. If you want to change it, then you've got to change the tool it's made, you've got to change it, you've got to consider what happens in spare parts, you've got all sorts of things. Therefore, change is driven in a very regimented way. On a construction site, change gets driven often right at the coalface, when a solution that was conceived by an architect 2 years ago, because it wasn't properly integrated with what's around it, doesn't work out in practice, and decisions need to be made. And therefore, technical people, engineers and architects based on site will make a decision in the call and address the issue. So the two isn't quite the same magnitude. However, when we get to our Buildoffsite and our MMC interface, the two worlds collide. And we need to recognize that if we're going to be efficient about building something in an offsite way, we need a stable design to build it to, because you can't design a manufacturing process around a stable design. So what we do is we have clearly defined time fences as lead into our factory, where we freeze design. We monitor our frozenness of design at a part or a system level ahead of that, and we measure our performance. So So we try to drive that rigor. It's nowhere, and equally, you'll recognise the challenges that puts back onto the project in terms of giving fixity of some elements much faster than perhaps otherwise would have done with conventional construction. But there is no rocket science to it. We do that with spreadsheets often. We do it with issue logs, and we use the tools that would be used in the car industry, for example, that are embedded in their operating platforms now. The management process is identical in our industry. The granularity is different.
Okay, thanks, Chris.
It's important.
Can I return briefly to Thomas and the question that was asked earlier? I think you suggested you'd like to respond to it on the, I think it was on the environmental side.
Sorry, which one?
The Andrew's question regarding the green agenda and the biodiversity aspects, and can we, I think, have greater biodiversity? Was that the right one, Susan?
Yes, that's the one.
That's the question by Andrew Powell.
That's it. I think, Thomas, you wanted to make a comment for Andrew.
No, I didn't mean to. I mean, I think it was a previous question. So sorry.
Understood.
Okay. So the question from Doug, can clients, through the use of detailed targets, time on site, waste, safety, quality, etc., force contractors to improve their MMC and DFMA offerings? As a contractor, Chris, could I ask you to come back on that first?
I was answering actually the question from Simon Millman, if I'm honest, Nigel, which is online. So I missed what you're saying because I was typing an answer to Simon. So if I may pick up that answer to his question.
Okay. The question from Doug Waters was, can clients use detailed targets in terms of time on site, waste, safety, quality, etc., to force contractors to improve their MMC and DFMA offerings?
Doug, the answer is absolutely. I think the client has an important part to play in driving that, but I would suggest that the client looks to what they want in terms of outcomes.
Yeah.
Drive more outcome-related targets than, shall we say, input-related targets, so that they're clear about what they want, and through discussion with their contracting partners, define those so that they stimulate a view to offsite and putting construction in the more, the beneficial areas of factories. Okay, thanks, Chris. I'm going to push on quickly because we're running out of time, but we've got a couple of questions here. Thomas, I think this is one likely for you. What are your experiences in applying MMC concepts to linear infrastructure rather than building construction projects? What are the challenges and opportunities?
The challenges clearly are that historically construction has been seen as a kind of a bespoke solutions, and I think that probably Chris would agree on that, and it's not very efficient, whereas other industries have been evolving very quickly and standardizing and making more efficient construction. Basically, in bridges, for instance, I'm leading the design of bridges and construction of bridges. In bridges, there has been very little evolution or improvements over the last 50, 60 years. We essentially keep doing the same thing, except for some good exceptions, of course. That is a challenge. As I said before, a good design is a very fine balance between very competing requirements. We are trying to standardize most of the solutions, try to identify scenarios where actually a same solution or a similar solution would solve the problem. And when we talk about the solution, it's not just a functional solution, it's not the most cost efficient. Bridges, for instance, and civil infrastructure is seen as a part of a kind of art, some architectural. People want to live close to a nice structure. It's going to be there for basically eternity in terms of human life. It's going to last hundreds of years, so basically it will outlive us. So that's the difficult balance to get the right functionality, efficiency, carbon, aesthetics, the whole thing. That's the challenge. The opportunities is that I think that we can have still get a lot of optimization, a lot of standardization, a lot of even standardization with flexibility to adapt to different solutions. And that's what we are trying to achieve.
Okay. Thanks, Thomas. Another question that came in, I think I'd like Vince's view on this, but I'll give an opinion myself as well, if I may. Could the push for standardization of products reduce the value associated with those products, reducing them more to commodity items and ultimately lower margins? That's from Simon Millman. What I would observe is that with a degree of standardization, and bear in mind that there's still quite a lot of scope for mass customization in our world nowadays, the great thing about having a degree of standardization is that you can actually go down a cost curve. And there have been many, many studies over time that show that cumulative production is very closely linked to a trend to reducing costs. And I would suggest that rather than that creating low margins, it offers an opportunity for both productivity savings to the client and to the manufacturer or the supplier. And actually the product margins in the profit margins in the product world are somewhat larger than they tend to be in the construction world. So I would have thought it was in all our interests to enable our industry to exploit some of these benefits over time. Vince, what do you think?
I think that's a fair summary. I understand the argument, and at senior level here in Polypipe, that is a discussion that we are having. My personal view on that, though, is that I think we should embrace it. Again, as an observation of what we're doing here in Polypipe Offsite, we're seeing, just by virtue of the projects that we're involved with, a series of our own product types, our product families. They start to resemble themselves. And again, the fact that we have done something similar in the past, we can then suggest that as an 80-20 design that is getting pretty close to meeting requirements earlier in the design process. So I think it's part of the natural evolution of this as a sector. I think it will evolve in that direction anyway. Again, personally, I think we're in a reasonable. I think it's going to happen. The benefits from our point of view as a producer is obviously we can systematize that, and the fact that we are digital throughout, and we can exploit those models and already have our CNC programs or pre-prepared, again reduces our own setup times, our own production times, and ultimately takes out cost, as you say. A final observation, though, I think we're miles from that today. That's a personal observation of where we are today. We theoretically, I think, if the sector could organize itself, it could march in that direction. But honestly, my personal observation of where we are today, we're not seeing that. You tend to get a Revit model after another Revit model, and even within certain offsite builders, some of whom have been mentioned today, even within their house types, within their own portfolios, there is very little shared platforms, even within the same company. So again, there is an observation that this is definitely a direction to go. As far as the MEP bit is concerned, we would embrace that and we would support that. But fundamentally, that's not what I'm seeing today.
Okay, thanks, Vince. I would say that for those people that are worried that standardization is going to result in boring buildings and boring infrastructure, behind this is a long-standing trend within manufacturing for what's known as lean production and lean manufacturing. And in that context, the ultimate goal is to be able to be economic in delivering single piece flow, which means very small batch sizes and very quick changeover times between the manufacture of different components. And when you get into that world, you actually can handle variety quite efficiently, but we need to help the construction supply chains get to the point where they can start to go down that route. We're not, as Vince said, we're a million miles away from it at the moment. But again, going back to what we've done at the airports in the past, we had a very good project with putting corridors on top of piers, and we had, I think it was 1.2 kilometers of corridor, but we had 64 different configurations of those modules, but they all went down the same production line with a very similar flow rate through the factory. And we made very significant savings on that project. But it demonstrated that if you look at a portfolio and you identify where the commonality is and you standardize on the things that are important to standardize, i.e. the cost drivers, you can actually start to drive a lot of efficiency through the process. Does anybody else want to make a final comment on that? And then I think we should wind up the session.
I'd like to only add, Nigel, that you should put the strap line on all of this of standardize the invisible, customize the visible. And direction of travel of a lot of government procurement now, schools, hospitals, prisons, wherever else, is to drive standardization of the invisible, which has to be the right way. And then that gives the opportunity for people like Vince and his team to really then drive cost out, because they can automate the process. It doesn't mean driving margin out, it's driving real cost out, because we're taking work out of it. And that's where we've got to orientate our efforts as an industry.
Okay. Thank you, Chris. And I'd just like to wind the session up and say thank you to Thomas, Vince and Jennifer as well. And thanks for everybody that's listened, and for those that have submitted questions. I hope we answered them for you. Thank you.